Hello, my name is Matt Flores, and I did my research on The Boring Company. This was a lot of fun learning about what the company has, where it came from, what it's been doing, and what it has planned for the future. And I'm really excited to present it to you in this video presentation. The company was founded by none other than Elon Musk. I'm sure a few of us are familiar with who he is, but just a few pointers about him and his career. He is an engineer, industrial designer, and technology entrepreneur. He is the 20th richest person in the world. He is founder and CEO of SpaceX, Tesla, The Boring Company, and also involved in a number of other companies and projects as well. He's known as sort of the Tony Stark of the real world, from the Iron Man character. He has been a resident of LA for the better part of 2 decades, and as a former LA resident myself, I know what it's like to sit in traffic in that city. It's horrific. And one of the days that he was sitting in traffic, I guess it just struck him so much he decided to tweet out, "Traffic is driving me nuts. I'm going to build a tunnel boring machine and just start digging." And he followed that tweet with, "I'm actually going to do this, and it shall be called The Boring Company." And just from that, one moment in traffic, he sparked the idea of, why don't we, tunnel underground and see if we can't accomplish a better way for public transport or individual transportation. And so he came up with the idea right then and there and used his creativity, his entrepreneurial mindset, and his financial resources to get that started and make it happen. Okay, so why tunnels? A number of different reasons why. One, there are unlimited layers. There's no particular limit to how deep you can go. You can put tunnels on top of tunnels on top of tunnels and go as deep as feasibly possible with the equipment that they have and the equipment that they're developing. We'll go into a little bit in that later. Weatherproof. Tunnels are known to withstand earthquakes, hurricanes, flooding, those kinds of weather events, and they stay intact really well. They can't hear, see, or feel the construction on the surface. When they completed their test tunnel in Hawthorne, Los Angeles, they came out the other end of the tunnel and the neighbors didn't even know what was going on. The neighbor was kind of unfazed by the construction that took place. Tunnels are unlike freeways. They do not divide communities. Tunnels are really unique in the fact that you can build infrastructure within a community without disrupting the fabric of the community. You're not going to get in anybody's view. You're not going to obstruct other traffic. There's no street closures. We're seeing that on Broadway and all over Tucson right now, that when improvements need to be made to the transportation system in our existing communities, that roadways need to be blocked. There's disruption. There's slower traffic, whatever the case may be. There's a lot of impact. However, with tunnels, you avoid almost all of that completely by keeping your construction completely underground. However, there's a few problems, a few challenges that come with constructing tunnels. Tunneling today, it's a very slow process. It takes usually 3 to 6 months per mile. It can take even as up to a year or more in some cases just to get 1 mile. It is 14 times slower than the pace of a snail, just to kind of put things into perspective. And that's using the current fastest tunneling machine in the world. It's still 14 times slower than a snail. And it's also very, very expensive, up to $1 billion per mile, and even more. So it's incredibly expensive and it's really slow. So obviously, starting off, there's a number of challenges that the Boring Company has got to meet in order to make this a viable option. One of the things that the boring company needs to do is they need to increase the speed. As we saw, it's about 14 times slower than the pace of a snail. And so to make this a viable option, they need to obviously decrease costs, but also increase the speed at which they create these tunnels. One of the ways that they do that is through automated segment erection and logistics. From what I gathered from my research is that tunneling, 10% of the time is just cutting through the soil. It's just advancing the auger. The other 90% is the logistics of removing the dirt, placing the segments, and installing the reinforced segments into the hole. And so what they've done is they've really sped up the process. They have this simultaneous mining and installation of the reinforced segments, so that way they can dig and reinforce all at the same time. Also, they've increased the power of the boring machine itself, and so that way it's able to obviously bore a lot faster. And they've gone through a number of different iterations of the actual boring machine, and they just keep improving it, making it better and better. They're able to allow for continuous dirt removal. So usually what happens is the boring machine, for standard tunneling, boring machine will go in, make the cuttings, and then they'll have to come in, remove all the dirt, and again come back to place the segments and reinforce the hole itself, and then go back in and dig some more. But again, they're just making it kind of one fluid motion. They also have a modified cutter design, so you see the teeth at the bottom of the boring machine. They're just continually advancing this piece of equipment left and right. Their goal is they want to have exponential speed improvement, and they ultimately want to be faster than a snail. So they're able to, they tripled the power of the boring machine, and they believe that they can achieve up to 5 times faster speeds through the simultaneous process that they've developed for tunneling. So they're getting there in terms of getting to be faster than a snail. They're doing much better. Decreased cost. Obviously, $1 billion per mile isn't very practical when they're thinking about the scale at which they want to do these types of loop projects on. One way to decrease the cost is on-site integration. They're doing everything on site. For example, a lot of times when tunneling occurs, they usually cut the dirt and then they remove the dirt and they bring in imported dirt for the reinforcement. However, Elon Musk is like, okay, well, that doesn't make any sense, so let's just use the same dirt. And as you see in the bottom bullet there, they're even using the same dirt to create bricks and sell bricks, because obviously you're going to have a lot more excess soil that you're going to have at the end of the project because of the hole you created. What are you going to do with that soil? A lot of times they just sell it to different companies, but in this case what they're going to do is they're going to keep it. They're going to make and sell bricks and be able to make that much more of a profit. And in some cases, Elon Musk even believes that through the sale of their bricks, they can pay for the entire tunnel itself. So that's a pretty ambitious goal, but he believes it can be done. Reduce the standardized tunnel diameter. Typical tunnels are a lot bigger, I believe 28 feet or larger. However, with these, only a 14-foot diameter hole is really needed for the vehicles that they have passing through them. So a lot smaller hole, a lot reduced cost. Also planning to use electric locomotive. Typically, it's like a diesel type of vehicle. There are countless issues with that, but with electric locomotive, they can reduce the cost. So their goal is exponential cost improvement. And we'll see from their test loop that they were able to achieve a much reduced cost at also a very expedited speed. So the first thing that the boring company did was they created a test tunnel. It's located in Hawthorne, California, and it's being used for research and development of the boring company's tunneling and public transportation systems. They obviously want to create more of these tunnels, and so they need a tunnel to test it out. Just a few questions and answers about this test tunnel is, where does this tunnel alignment run? It's at their SpaceX property, and it's about a mile, just over a mile in length. This project was completed in December of 2018, and it only cost $10 million. Like we said in the previous slides, that typically 1 mile stretch of tunnel would cost up to $1 billion. However, they were able to reduce that cost through some of their revolutionary techniques and the size and so forth. Why are you building an elevator, a loop lift, in a garage in a house in Hawthorne? So one end of the test tunnel is could fit within the size of a house garage. And they wanted to do that because they wanted to demonstrate that a lift can be built in very small footprints within existing buildings, whether it's a house, office building, retail parking lots. And looking forward, one could have a lift in the basement of an office building. This could allow extremely convenient commutes. And a lot of people are asking, can they get in the tunnel? Can they test it out? And due to unbelievably high demand, tours through the Hawthorne Tunnel are by invitation only. And as a matter of fact, I'm going to show a video here in a second of this test tunnel on display. Well, they're going to have one vehicle on the left taking the streets from one end of the tunnel to the other end, and the gentleman on the right, he's going to actually go down into the tunnel and go through it out the other end. We'll see kind of the compare and contrast about the speed and convenience of the tunnel. So it's pretty cool. As you saw in the video, the gentleman that took the tunnel was able to get there nearly 3 times faster than the gentleman who took the roads. He was able to reach, I believe it was up to 127 miles per hour in the tunnel. And being in the tunnel, they're even on little tracks that allow safe and smooth ride through the tunnel. Obviously, being able to just go, not have to wait for traffic, not have to stop at stoplights and so forth, able to just go from A to B pretty seamlessly. So it's pretty impressive. So what is the Boring Company? What all do they do? Their number one goal is to create a loop transportation system. Elon Musk got into it because he wanted to alleviate congestion on highways. He wanted a better way to get from A to B without going through traffic. And so that's where he created this loop transportation system comprised of twin tunnel stations, one on each end, obviously, ventilation, exit shafts, loop vehicles, and internal system including lighting, communication, video, fire and life safety components, and should be able to accommodate passengers and or cargo if you're just shipping goods. Also, what the Bourne Company does is they can be hired and contracted out for conduit tunnel, for example, for utilities, for water tunnels. They could very easily go in and create these tunnels for multiple utilities without surface disruption, including tunnel application for internal systems as well. So it's really multifaceted what they can do. It's not just for transportation, could also be used for utilities for different municipalities. The loop itself. So what's the whole purpose of it? What does it consist of? It's intended for autonomous electric vehicles. Again, like I said, that line up not necessarily on tracks. It is a roadway, but they have wheels that come out the side that ride along like a track. Also, it's intended to have multiple stations. So one downside to, say, like the subway system is that it goes so far and then stops at a certain station and unloads, loads of people. However, those people might be still far away from their destination. However, with the loop, you can create, again, countless stations, because it tends to have kind of a main artery that travels speeds of up to 150, 155 miles per hour, and then could easily slowly exit to a nearby exit station, and you can have as many of those as desired. Again, because it's underground, you have a lot of opportunity there. The elevators can be either spiral, ramps, just the drop elevators. A lot of times what they plan to do is, again, install these, or I should say construct these off-site, and then once they're fully fabricated, bring them on site and install them to, again, just alleviate construction zones and things going on in the community. They could be fast and low-cost tunnels. As we've seen, they've been developing continually their tunneling system in terms of cost and speed. It's great because it's 3 dimensions. There's no limit to the number of tunnels. Unlike a freeway, it's just a flat plane and there's only one way to go. However, with the tunnel, you can do, again, multiple tunnels, and again, it's pretty open to how many you can do. And it allows for an express system where it's just going to be quick and easy. You can get to a nearby exit station, and we'll see here in some future projects that they have, they're planning on plenty of stations, for example, in Vegas, where you can get pretty close to your destination from their exits. For example, this is for the Las Vegas Convention Center. This is an existing project in the making right now. Now, this is not necessarily for vehicle transportation per se. It's more for just individual personnel transportation across the Convention Center campus, which is rather large. It can get these people from A to B. It's actually the Boring Company's very first commercial project, and it's currently in construction. It's approximately 40 feet below existing grade, and instead of attendees at the conference center walking across the campus in 15 minutes, they can take the loop tunnel and get there in just over 1 minute. They plan to, again, use autonomous electrical vehicles. These would be more of a shuttle vehicle, not your typical Tesla vehicle or standard sedan. And it's expected to be completed in 2021. So if you're ever in Vegas, be on the lookout for that. It's going to be pretty neat. This is the Vegas Loop project, which is not quite official and finalized. It has still a few things to go. The Vegas Loop could include many different service extensions, including those shown on the map. You can see in the solid blue line, that's the Vegas Convention Center loop that we just took a look at. However, this could be for the entire city going across the Strip. During typical peak hours, driving from the Vegas Convention Center to, say, the Mandalay Bay, for example, could take up to 30 minutes. However, with this Vegas loop, it will take approximately only 3 minutes. And again, as you see, there's multiple stations that can take you to specific hotels, specific casinos, nearly right to their doorstep in minutes rather than half an hour or more getting from point to point. They have a lot of future projects in the works. These are all potential. They're working through, you'll see, environmental review and permitting, contract review and permitting, that they got going across the country from LA, Chicago, and in the Northeast, DC, Baltimore. The Dugout Loop in LA, it's planning to connect Dodger Stadium to a few of the neighboring communities, including Los Feliz, East Hollywood, and Rampart Village. And if you've ever been to a Dodger game, you know how bad it is getting out of a Dodger game. Traffic, it's one way in, one way out, and it's just horrific getting out of Dodger Stadium when the games are over. Chicago Express Loop is planning to go between O'Hare Airport and Block 37 in downtown Chicago, transporting people to and from the Chicago Express Loop. And also they have planned the East Coast Loop from DC to Baltimore, connecting those two communities. Again, these are projects in the works, but look like they plan to be moving forward. And as Elon Musk said, one day it will connect to the Hyperloop. So one of the goals that he has is to incorporate his SpaceX company, Tesla, and the Boring Company all in one to have a Hyperloop potentially underground connecting communities at far distances. So it's pretty interesting. I had a lot of fun researching this topic. And let me know if you have any questions. I don't know everything, obviously, but it was really neat studying this out. Thank you.